Okay, so we had a question in class that right at the end that I wasn't able to answer satisfactory, and so let me go ahead and answer that right now. So the question was, why is it that our volume using our cylinders or our cylindrical shells, why is it 2 pi RH? Okay, dx or dy. And so what we want to look at is what's happening. Emily had asked in class about, with the example I had shown at the end, y equals the square root of x, and she had asked the question of, are the shells solid? And I told her yes, but they're not. I misspoke, because basically what's happening is we're coming in, and there's the other side, okay? And we're coming in and we're cutting these shells out. And so they come in like this, and they're rounded here. But we start like at the very, very middle with the smallest shell, and then we keep going wider and wider and wider. So what's happened is we've already cut out the inside pieces. So each shell that we make is a little bit wider than the last one, okay? So it's coming down here and it's a little bit wider, and then the next one is a little bit wider. But because we've already cut out the ones in between it, then there's no inside. So it is a paper thin, actually a thinner than paper slice of a shell, and it is always hollow. Even though our solid is not hollow, the shells that we cut out will always be hollow. So what we're going to do is actually calculate the area of the shell and then add all of those areas up, just like we've been doing with our other volumes, our volumes of revolution. So when we had one that looked like this, so that it revolved this way, we're actually calculating the area of each one of these slices and then adding them all up. So here was the volume, ended up being pi r squared, which is the area of the circles that we were cutting out. Well, what we're going to do is add up the areas of these hollow cylinders that we're cutting out. So the area really is just the surface area, the outside of each of these cylinders. Well, that outside, you could cut down one end of it and open it out, and it ends up being a rectangle. Think the label of a soup can, right? So our area is going to be height times this distance here. Well, that distance is the circumference of our base, right? And so it is going to be 2 pi r. Okay, so our volume is 2 pi times r, which is the base, times the height. And so that's why, and then we add up all of those areas, those super thin slices, and when we add them all up, then we'll end up getting the volume. We'll talk about this some more tomorrow. I apologize for the scribbles. Y'all are used to it. No, I can't draw. It was a great question. I'm sorry I fumbled it there at the end as we were so close to the bell, but that's the explanation of where the formula came from.